So welcome back. Next up is Vanja from Qoitech. And she's going to tell everything around the right tools to build low-power IoT devices. Enjoy her talk.
Hi, I'm Vanja, CEO of Qoitech. For the past 3 years, me and my team have been devoting our time to support and learn from our customers, developers, and teams in introducing, evolving, and maintaining a low-power mindset in everyday development tasks of their IoT devices. Now, you may wonder what I mean by low-power mindset. A low-power mindset is understanding that making something energy efficient may be complex and sometimes a tedious task. Yet it's both rewarding and extremely crucial for your business. It's about understanding that you can achieve this by implementing a few important practices that are utilized by the developers as well as the team. Getting into the low-power mindset means continuously measuring and optimizing the energy consumption throughout and even after the development project. Sounds simple, right? Especially since most of us are testing continuously for many other purposes. Yet measuring power consumption and energy optimizing has been rather a quick check in the beginning of the development and the recurring firefighting task. I don't have to tell you why you should do this, but let's rather talk about how you measure power every damn day. If you haven't found the perfect design for long battery life yet, you're most likely struggling with its complexity. It's not enough to have ultra-low power chipsets and sensors. You need to understand your user scenarios, write smart software for those, match these to the hardware and battery that you've chosen, and of course, understand how all these will work in the network, in the different environments, and in the hand of the user. Yet both you and your customer want long-lived devices and preferably not long and expensive development time to reach that. Let's see what this means in the context of the development process. For simplification, I'm going to divide this process into 3 parts: the prototyping phase, development phase, and the production and maintenance phase. You're entering the prototyping phase with hopefully well-documented use cases, scenarios, and requirements on the energy efficiency of your product. You most likely have a form factor in mind and also physical size of a battery to fit that form factor. You probably also have decided to try one or few different low-power technologies and hardware to build your case upon. Practicing low-power mindset in this phase means following. Pick a preliminary battery. Early on, especially with no access to the prototypes or dev kit, you base it on your use case and requirements. SAFT has a useful tool for this purpose, the IoT battery selector that you can use. Then go back and edit the parameters and play to find the solution that works for you. There are also simulation tools available for this purpose like WiseBat and our partner Deutsche Telekom's IoT Solution Optimizer. When you have something to measure, start measuring. How profile your device for different scenarios and technologies. You're perhaps considering a cellular fallback to your LoRaWAN device. If you have dev kit for it, this is the time to test it and see what it would mean for the power consumption of that specific corner case. Ask your hardware supplier for an OTI file showcasing the energy consumption profile of the chipset, module, or sensor for a couple of duty cycles. Real measurement beats PowerPoint performance any day, and it's great insight in addition to your data sheet. It also gives you and your supplier a reference for discussing the hardware that you're using and the behaviors that you're seeing. Be aware that the performance changes when you apply your scenarios and your software on top of the hardware. So measure for every change that you do to track and to learn the behaviors of your hardware. Start estimating battery life. The goal is not to get the absolute value, but rather to learn what impact different power profiles have on the battery life. You can use the OTI battery life estimator when measuring power with OTI by picking the information from the power profiles and estimate it with the battery that you have preliminarily chosen. When practicing this, what you bring into the development phase is the idea on how to optimize your design, what key parameters to follow up on extra, and how to make it all more efficient. Practicing low power mindset in development phase means the following. Automate your power measurements. Development is an iterative process, and your energy optimization will depend on whether you have included power measurements for each of the iterations made, whether they be in hardware, firmware, or software. This is no different than having automated tests to find firmware and software bugs to detect performance degradation, high memory usage, or memory leaks. And now that there are tools to enable this, like OTI and the OTI Automation Toolbox, it is easy to add energy consumption tests to the existing test environments like Jenkins, with tests written in popular languages like Python or Java. If you have continuous integration setup running already, integrate power consumption measurements as part of it. Practice pre-testing on every development's bench. There is much to gain from every developer testing prior to committing to a new firmware or software release. Add to minimize the tedious and manual work of connecting and disconnecting between a debugger and power measurement unit, we can use a simple switchboard. We have created one at Qoitech, and our customer Inas have one available on their GitHub, so that's worth checking out. Profile your batteries. In this phase, you need to step up your battery game. You have picked a preliminary battery, and preferably few from different brands as second source or benchmark. If you know that perhaps your customer will replace the battery at some point in time, you need to have checked that also those potential choices work in your device and for your purpose. By profiling batteries, I mean measuring discharge performance over time for these batteries based on your device power performance that you now have been perfecting since the prototyping phase. This way you will gain a realistic insight whether these batteries have the capacity and the right behavior to support a number of scenarios that your device will be in. And yes, you need to do this for the normal usage and for as many scenarios you believe are relevant. If it is relevant for your user case, also profile these in different temperatures, since battery performance are very dependent on that. You can use the more realistic battery capacity from the profiling in the OTI battery life estimator, since you should continue to estimate battery life for every change made during the development. You can further improve the accuracy of the estimation by applying the profile battery discharge to the device, instead of powering it with power supply, for example, to find out what the actual usable capacity would be. We call this battery emulation, and trust me, you may in some cases only see 10 to 20% of capacity being usable. With the OTI battery toolbox, this can be manually done by applying and changing the used capacity to your device and observing when the device shuts down or reboots. Of course, you can also automate this with the OTI automation tool. Finally, what does practicing low power mindset in production and maintenance mean? Well, the following. Now that you are practicing automated testing in development, it is a small step to introduce this in production. And of course, even smaller one in the maintenance. By using an affordable and easy to use setup like OTI, it's easy to have the same methodologies applied at your suppliers as well as your manufacturers. This allows for the same reference point when discussing requirements and deliverables, and minimizing the risk of error in testing. And in the maintenance phase, it is as important as during the development phase to make sure that any fixes in the firmware or software doesn't do irreparable damage to your already installed base of devices when distributing updates. You don't want all your hard and smart work during the development to vanish by draining the batteries in your deployment with a line of code meant to fix something else. So low power mindset is achievable, and that rather quickly. It is mostly based on continuously measuring and already practiced automated testing. With having the right tools, comprehensive for the task, yet affordable and easy to use, to be scaled across the team and development chain, this is a no-brainer. Embrace it and contact us to show you what can be done with our products. And yes, measure every damn day.